All right. So example 14, part A and B. So we're working on example 14, A and B. Now part A says, if the acceleration of this block being equal to the 15 Newton force is 1, what's the coefficient of kinetic friction, correct? Right, is that the question we're trying to figure out? Yeah, what's the coefficient of kinetic friction? So if I want to find my coefficient of kinetic friction, that's this mu, sorry, wrong mu, that mu right there, okay, in my kinetic friction equation. Okay, so that's what I need to find. In order to find that, what's the first thing I need to do? Find Fm. We need to find our normal force. That's part of my equation, right? So to find the normal force, do we look in the x direction or in the y direction? The y. We look in our vertical direction, right? Right. In our vertical direction, is this block accelerating? No. So then we know that F net, which equals ma, we know this a is 0, right? So we know F net equals 0. Right? Does that make sense? Yes, Kim?
If it was moving up and down, that's when A would have a number?
Yep. So if we were riding an elevator and doing this, and the elevator was accelerating upward, then that kind of sounds like a fun problem. That might be mean. Yes, Kevin?
Isn't it gravity?
Is the block, if the block was in free fall, then our acceleration would be 9.8. But the block's not in free fall, it's resting on the surface. Okay? If the block was in free fall, there wouldn't be any normal forces. Okay? So, net force acting on the block, we have Fn, we're assuming up is positive, minus Fg equals 0. Does that make sense? Yeah? So, by adding Fg to both sides, we get Fn equals Fg. And since Fg equals mg, we know Fn equals 5 times 9.8, which equals 49. So that is the normal force. All right? We use the vertical direction. Does that make sense? Okay. Now the horizontal direction. Oh, that's in part piece. Ahead of myself. Okay. The horizontal direction. In the horizontal direction, that's where our pull acts and our friction, right? So by using Newton's second law in the horizontal direction, we can figure out this mu k. So in the horizontal direction, what's our net force equation look like? Okay, F net always equals ma. Great place to start. We know this A is what? 1. We know m is 5. So we have 5 times 1 equals something over here. What things are over here? Good. Force pull minus force friction kinetic. Right? Does that make sense, guys? Does that make sense? It's just Newton's second law like we've been doing for 2 weeks now. Right? That's all it is. It's the same thing we've been doing for 2 weeks, but now we just have another equation to plug in. Another equation to plug in for a force. The pull, they said, was 15 newtons. Force friction is mu Fn, right? Because kinetic friction equals 5. Right? We know Fn is what? 49. So we have 15 minus 49 mu equals 5. What do I do now? Subtract 15. So negative 49 mu equals negative 10, right? What do I do now? Divide by negative 49. So we know that mu equals negative 10 divided by negative 49. So what does mu equal? Just under 0.2, right? It is 0.2? Exactly?
No.
0.204.
0.204? Okay, just over 0.2.
Mr. Branch.
Yeah.
On the second step, F ball minus F friction over kinetic whatever.
Yeah.
Did you change that part for the MKFN?
MuKFN? Yeah, it's right
The
here.
second part you changed it?
Yeah, this is MuKFN. That's right here. Force friction.
Because I just put F friction.
And you found that number? So you found the force of friction as being. The force of friction is -10? Yep. So you just did negative. So you have this equation at the end, right?
I didn't put in the 49 because I didn't change the rule.
Okay, so you just found the force of friction is -10? Okay, that's fine. And then what are we going to do next?
Put it in.
Use this to find mu. Okay, that's fine too. So guys, what Kim is saying is she kept this force friction the whole way. She found the force friction as being -10. And then then now she's going to do -10 equals, plug the -10 in right here, and solve for mu k. That's another way to do it. Any other questions? What does part B say? I forgot. Part B. You try to measure the coefficient of static friction by applying a 6 Newton force on the 5 kilogram, and the 5 kilogram mass does not move. What is the force of friction acting on the 5 kilogram mass? All right. So part B. So now we apply a 6 Newton force, right? Right? And it does not move. So what type of friction is acting? Static. Good. So if we draw a free body diagram, Fn and Fg are still there, right? Right? Now our force pull is 6 newtons, right? Acceleration is 0. So there's no movement. Okay? So this is our force of static friction, right? Right? If we're not moving, what has to be true about these two forces? Sorry, not just not moving, but not accelerating. These two have to be equal. Because we know F net equals ma. So we know the 6 Newton pull minus the force of static friction equals 0, right? So 6 newtons equals force of static friction. Does that make sense?
Yeah.
Does that make sense? Okay. Can I figure out the coefficient of static friction now? Because our static friction equation is this. Can I figure out mu s? No, I can't. Because this is the maximum value, right? This is the maximum value. This 6 newtons is just what it is right at this moment. We don't know what the maximum value is yet. All right? I know that 6 will be less than this. Okay? So by solving this for mu s, I can find a coefficient that's less than our mu s, but I can't find the exact value. In order to find the exact value for mu s, you have to look at just the moment right before the block does what? Right before the block accelerates, before the block starts to slide. Any questions?